Hello everyone, in this video I will explain you naive-based classification with example and mathematics. So let's start this video. So naive-based is the method used in supervised learning for classification. So what is classification then? Classification is used to predicting in categorical data. Example, predicting the category of a car. Is it old or new? Naive-based is based on Bayes theorem. Here probability has a very big role because Bayes theorem is based on probability. In naive-based, Bayes is Bayes theorem, and naive means all the variables we are using here is independent in each other. Hopefully you are understanding this. In order to understand naive-based classification, you first need to understand Bayes theorem. So let's see what is Bayes theorem. I will show you with example. Okay. There is a Tesla showroom. Okay. That sell Tesla cars. This is the showroom. Okay. And that showroom has 3 model Y, okay, model Y, and 5 model 3, okay. So you buy a car from there. So what the probability of you having model Y? So you can easily do that because we are talking about model Y, probability of model Y. So we can do 3 and by total here, which will be 8. So we have 3 by 8 probability of having model Y, okay. So another example of it will be this. Here you can see that sorry. So here we have 2 showrooms, showroom 1, showroom 2. So showroom 1 have 2 model Y and 5 model 3, and showroom 2 has 5 model Y and 2 model X. Model 3, sorry, model 3 it will be here. Model 3, okay. Model 3. So what is the probability of you buying model Y from this showroom, any of the showroom? So we can easily calculate this. First, we will need to find the probability of this showroom, that what is the probability of buying from this showroom is. So 1 by 2, okay. And here this showroom also 1 by 2 probability of buying from this showroom, and buying the model Y from this showroom 1 is the probability of 2 by 7, and buying model Y from this showroom 2, the probability is 5 by 7, okay. Now we can easily find the probability of buying model Y from these showrooms. So that will be easily 1 by 2 multiplied by 2 by 7 plus 1 by 2 multiply 5 by 7. So you can easily do this value and you will get the probability value, the probability of model Y. What will be the probability of buying model Y? This maths which you have seen today, this is not Bayes theorem, but this will help you understand Bayes theorem. So now we will look at Bayes theorem. This example will help you understand Bayes theorem. Now you are buying a Tesla and that Tesla model is already given. You are not predicting the probability, okay. That is given that you are buying Tesla model Y, and that is given that you are buying Tesla model Y, but you have to find the probability that you are buying from showroom 1. So we have to find the probability of that we are buying from showroom 1. So this is the formula to find probability of that. This is Bayes theorem, okay. So here this is X. So what is this X? So this X is an independent variable, okay. And this is the value, which this is model Y, and this is showroom 1. We have to find that this model Y is from showroom 1. We have to show that. So how we will show that? X divided by Y. So here X is model Y and Y is showroom 1, okay. And here Y is showroom 1. So here we will give this, we have to give the probability of X by Y, so which is model Y and showroom 1, so which we have already, that is here probability. We have to give the probability is 2 by 7 here, okay. The probability is here 2 by 7, which we have to give the probability of showroom 1 of model Y. So here we will write 2 by 7 into PY. So Y we have to give Y is showroom 1, which is 1 by 2, okay. That we have to give here 1 by 2 divided by probability of X. So what is probability of model Y? Total probability we have to give here, which is this. We have to calculate this, and then we have to put it here, total number here, and then we will calculate this, and then we will get the probability that this is from showroom 1. Okay, hopefully you are understanding right now. In real world we do it like this. We don't have one variable like this, independent variable, like here you can see that independent variable, that in model Y. In real world we have multiple independent variables that are independent in each other, like x1, x2, xn. Okay, here, and this is our Y. So if we are predicting like this, if the car is new or not, yes or no. So if we are predicting like this, yes, so here we will predict the value that this is yes or no according to this factor. So like this, here we have put in x divided by y. So for every factor like this independent variable, we will put here x1 divided by y, x2 divided by y, x3 divided by y. Okay, and now here into py, which is y is our yes. Okay, probability y, which is yes, and here is the probability, like I have shown here. The total probability here goes with that. You have to do it here x1, x2, x3. Okay, and here you will do it for no, that car is not new. You will do it for no, that car is not new. Okay, so that car is not new. Okay, no. So you will check the probability that that car is not new. Okay, by according to these factors, independent variables. Okay, you will do it same here, and this thing is same. You can see this thing is same. So we don't have to write always this. We can just look at this, because this is the main result, and we have to divide by same for dash 2. Okay, so by doing this we get the percentage that if the percentage that the car is new is 80% for example. Okay, and no percentage is 20%. So we will look that which percentage is higher. If no percent is higher, for example it will be 80 and this will be 20, then this will be no will be the answer. But here yes, for example yes is 80%, so that means yes is right. So that we have to do it here. You have to find that which has highest percentage, and according to that predict that it is yes or no. Okay, so this is Bayes theorem, and this is how naive-Bayes classification work. Okay, so now I will show you the example of it. So now here is the example. Okay, so this is the data which we have. This is x1 and this is x2. Both are independent variable. This is which we have to predict yes or no. Okay, this we have to predict based on this data. So this is the data of patients, multiple data, which means that if this person have COVID and do not have flu, that means this person has fever, like this data. Okay, because we have multiple data, we are just not looking at 1% data, because it does not mean that one person has COVID and he has fever, so another person come and he have COVID will have fever. We have multiple data. So how we will use this data and calculate? Let's see here. So now we have this data of patients. According to this data we have to predict that they have fever or not. So where we will predict? So here we get a person data. This is a person data which have flu and COVID. So first we will check that this person has fever or not. So we will check that this person has fever or not, and we will get the percentage here according to like this, which we have done before. That formula you have seen, this formula according to that we will do it. And second we will do according to this formula, that is this. We will check that if this person don't have a flu, don't have fever or not, and we will do like that from that formula. Okay, and which percent will be higher, that will be right. For example, if there it will be 10%, 20%, and this will be 10%. So this will be he has fever. Okay, we are predicting like that. So here when we are looking at yes, so here we have flu and COVID, and flu, P is flu and yes. Okay, into P, and COVID is equal to yes into PS divided by flu and COVID. And here also divided by divided by flu and COVID, but we are not using here because we have to divide by same, because here will be also flu and COVID same value divided by, and here also same value flu and COVID divided by. and this is for no. So here x1 x2, so here it is yes, and x1 x2, which is our flu, yes, flu and COVID. Okay, so x1 flu COVID is equal to yes and into p, and flu is equal to yes, and we are divided by yes, p is equal to yes. And here we are not dividing by this value, dividing because this and this value of no, that is same, that's why we are not dividing. And from here no, we have to do no and COVID flu, so COVID no, flu no, and here divided by no. Okay, and that's how we get the highest percentage here, 80 or 20, whatever, and then we will select which one has the highest percentage, and that we will select, and we will get the predicted data. Okay, so step 1, first we will take out prior probability. That is, first we will check that fever probability is equal to yes, how much. So we will take that from total data. So total data is here how much is yes of fever. Okay, 1 2 3 4 5 6 7 8 7. Okay, so here 7 and total value 10. Okay, and fever no, so fever no 1 2 3. Okay, 3 by total 10. We are taking this prior probability here. Step 2, condition probability. So here we will check that for COVID yes and fever yes, how much is there. So COVID yes 1, fever yes 2 here, 3 here, 4 here. Okay, so we have total 4, COVID 4, and total yes of fever how much we have, that we have already calculated here, 7, 1 2 3 4 5 6 7. Okay, here, and flu yes and COVID yes how much, 1 here, 1 2 3. Okay, 3 by 7, that we have done over here, that we have gotten here 7 of how much time fever is there. Okay, so here we will do same thing for no, that is COVID no and flu no. So we will check how much that is, 1 2 where is 2 here, and total we will get that 2 by 3. Okay, total no is here, fever no is 3. Okay, and for flu we will check that same, no flu and no fever. Okay, so no flu and no fever 1 2, and total we have gotten this 3, or total 2, we have gotten 2, and here fever how much time we have gotten, no 3. Okay, so first we will check this, so we can and get the value, so we can directly put this in this formula and we can get our result easily. So what we have to do is here, so here flu is yes and fever is yes, so here it is fever. Okay, so what we will do here is we will check for flu yes 3 by 7. So now here we will put 3 by 7 into COVID yes, fever yes, so that is 4 by 7 here. So here we will put 4 by 7 into probability of yes. So probability of yes is here 7 by 10, which we have already calculated. That's why it is now easy for us to put that values, 7 by 10. And now we can cut this, and 4 minus 4 to 12 and 70, 635 is equal to 0.17. So we have now 0.17. Now we will do it for flu no and fever no. Okay, so here we will do it, which is our value 2 by 3. Okay, flu 2 by 3, and COVID also here, which is no and fever no. Okay, so we will do it 2 by 3 into 2 by 3 multiply by probability of no. So probability of no is equal to 3 by 10, so which we will put here. Okay, let's put 3 by 10. So this cut. Okay, so now we have 4 into 30, 12 by 15, 0.13. So now if a patient come to you with flu and COVID, so what will be the probability of him having fever? So the probability of him having fever will be yes, because 17 is more than 13. Okay, 0.17 is more than 0.13. So that's why we will predict that this is yes. Okay, hopefully you have understand it.
If you want more exclusive videos, or you want me to make a personal video for you, if you want me to answer your questions, you should click the top link in the description. That will take you to my school community, which is made for people who love machine learning. By doing so, you will get exclusive videos there, answers to your questions, and personally videos made for you according to your request. By doing so, you will support me and this channel because I am doing this full time and this is my only job. Thank you.